Some people call it an ogive, some people call it an ogive, but it doesn't matter. Let's take a look at what is happening. The table below shows the monthly salaries of 100 employees at Adams Law. The question 1.1, draw an ogive, a cumulative frequency graph. I think let's use that, cumulative frequency graph. But what do you guys think? Is it an ogive or is it an ogive? To represent the data given in the table. So monthly salary in 1,000 rand, and then number of employees, and then in the last column we have the cumulative frequency. In order to draw the cumulative frequency graph, we need the cumulative frequencies first so that we can do that. And how do we do that? Let's take a look. So 0 to 10,000 we have 3 employees, so the cumulative at that point is 3. 10 to 20,000 is 4 employees, so the cumulative is 3 plus 4, so that is 7. And then we move to 20 to 30, there's 13 employees, so 7 plus 13, that gives us 20. I'm sure you can follow the trend now. So we're going to have 20 plus 20 gives us 40. 40 plus 21 gives us 61. 93 plus 5, 98 plus 2, 100. So that is the cumulative frequency. So now we can draw our cumulative frequency graph. When we come to our provided graph here, we already have the cumulative frequency on the Y and the salary on the X. So let's take a look. 0 to 10, the cumulative frequency is 3. So here is where we have 3. So 0 to 0 is always it's 0, and then 10 to 0 to 10, we know that the cumulative frequency is 3. So if this is 10, we know that we have 5 here. So 3 should be somewhere there, right? And then 10 to 20, we have 7. So 7 should be somewhere here. And then 20 to 30 is 20. So 20 to 30 is 20, right there. And then 30 to 40 is 40. 30 to 40 is 40. So we go up there. And then 40 to 50 is 61. 40 to 50 is 61. So somewhere there, just slightly above the line, right? And then 50 to 60, we have 73. 50 to 60, we have 73. Should be somewhere there. And then 60 to 70, we have 85. So 85 is there. And then 70 to 80, 93. 70 to 80, 93. 93 is there. And then 80 to 90, we have 98. 80 to 90, we have 98. Just slightly above 100. And then 90 to 100, we have 100. So we have it here. So that's those are our coordinates. Now we just need to plot them. So let's go ahead and do that. So let's see. Let's join all the dots and see what we end up with. Right. So there we go. There we go. That is our cumulative frequency. That is 1.1. Let's take a look at 1.2. Use the cumulative frequency graph to determine the number of employees that receive less than 35,000. So let's take our ruler because we're going to need it and go to where we find 35,000. So 35,000 is here at this point. That is 35,000, right? Because that's the monthly salary in thousands. So 35,000, we draw a line until we touch the cumulative frequency. So let's go up. Well, it's too thick. Let me just do this. All right. So 35,000. Let's go up. And then now we go left to find the cumulative frequency. So somewhere around 30, 31 there, 29, 30, 31. Yeah, depending on how you plotted your lines, right? So what is the question saying? Use the cumulative frequency graph to determine the number of employees that receive less than 35,000. So it's 30, 31, 29, somewhere there. But I think I'm slightly above, so let me go with 31. So the number of employees that receive less than 35,000, with depending on my cumulative frequency, the way I do my cumulative frequency is 31, right? And then for some people it's gonna be 30. For some people it's gonna be 29, depending on what you have. So less than 35,000. So less than 35,000, yeah. So 30, 31, 29, somewhere there. Yeah, I'm going with 31 because I'm slightly above. Yeah, I'm almost touching 32 there. So that's why I'm saying 31. Still reasonable. And then if we were looking for the number of employees that earn more than, then we would say 100 minus 30, which will give us 70. Right. Determine the median of the data. Determine the median of the data. So how do we determine the median of the data when you are given a cumulative frequency graph? The total cumulative frequency is 100, just like we saw when we were sketching the cumulative frequency graph. So halfway through 100, we have, so that is 100 divided by 2. So we have 50. And when the cumulative frequency is 50, that is where we are expecting to find the median of the data. If it was 70, then we're going to divide that by 2 and find that midpoint. So here, because it is 50, we would go to 50 along the cumulative frequency. So that is, let me just change the color. Right. So we go from 50, we touch the cumulative frequency graph, and then we go down. So when we go down, we end up at 45,000. So the answer to 1.3, the median salary is 45,000. And then 1.4, the monthly salaries of 5 employees in the interval 80 to 90,000 are given below. 2 employees from the interval 70 to 80,000 are promoted and receive monthly salaries of 83,000 and 84,000. Okay, determine the mean monthly salary in the interval 80 to 90,000. So in addition to 1, 2, 3, 4, 5, we have 2 from 70 to 80 that have been promoted. So we also have 83,000 here. We also have 83K, and we also have 84K because they've been promoted and now they're earning between 80 to 90, right? Determine the mean monthly salary in the interval 80 to 90,000. So we just add those numbers and we divide by n, the number of salaries. So that is 84,000 plus 85,000 plus 87,000 plus 89,000 plus 83,000 plus 84,000. So we have 1, 2, 3, 4, 5, 6, 7 people there. So when we divide that by 7, so the mean here that I'm getting is 85,857.14. The marker location is 1, so I don't think it's even necessary to show the work in here. So that is 1.4.1. 1.4.2, calculate the standard deviation in this interval. So if I'm going to need to find the standard deviation, I will need to enter the data in my calculator. That is the easier way. So I'm doing that right now. If you don't know how to use the calculator to find standard deviation, mean, mode, and so on, watch my other videos on stats, because I've done a couple of videos where I actually show my calculator and how you do these things. So I'm hitting alpha mode, right, on my Casio calculator, and then 2 is stat. So I hit that, and 1 says 1 variable. So I hit that, and then now I can substitute my data points. So I've entered the data, I press AC shift 1, and then I press 4 for variance, right? And I think standard deviation is option 3 on my calculator. I can see the sign there, and then when I press that, I get the standard deviation being equals to 2,294 1.63, right? And then 1.4.3 determine the percentage of employees whose salary lie within one standard deviation of the mean. Lies within one standard deviation of the mean. So we know that we're gonna say mean minus standard deviation. Mean plus standard deviation. We want to find our range for one standard deviation within the mean, right? So the mean is 85,857.14 minus 2,294.6. I'm getting 83,562.54, right? And then plus, let me see what I get. I'm getting 88,151.74. So I'm looking for the percentage of employees. So obviously I need the number of employees first so that I can ultimately find the percentage. So what is less than 83,562? 83,562. This person ends less than that because 83,000 is less than 83,562. And who earns more than 88,151? These two people earn more than 88,151. So 3 of the 7 people. So 3 of the 7 people. So that is lie within. So 3 is the people that lie outside one standard deviation. So the people that lie within one standard deviation of the mean is 4. So 4 over 7 multiplied by 100. So 4 over 7. My calculator is still in stats. 4 over 7 multiplied by 100. That is 57.14%. So that is the percentage of employees whose monthly salary lie within one standard deviation of the mean. There we land.